Okay, so now we'll take one more example. The sum actually it is there in the exercise. Same to same sum. F of x equals to x into log x. And here also same, we have to determine the maximum and minimum value of the following function. As here we have f of x equals to x into log x. But here when you will see the pattern of the question, it is little different. Yes or no? Previous this two sums which we had tackled, the function it was in terms of algebraical. Here the function, it is a combination of two things, algebraical as well as log. Okay, so log is attached to the algebraical x into log x. So clearly we can see that the sum, the pattern here, it is little different. And before dealing with this sum, you must know some basic concept, basic needs and deeds about the log part. If you don't know the basic things about the log, which was there in your uh, 11th standard, as well as this all things we had did in the derivative, the basic things about the logarithm. Without knowing the basic concept of log, so this sum, it will be difficult for us to solve. So first, before dealing with this sum, we'll see the basic concept of the logarithm. As here the first one is what? Log a raised to m. So log a raised to m we can write as m into log a. I hope you all might be knowing. Suppose if it is log 2 cube, so this we can write as what? 3 into log 2. Okay, or else if it is m into log a, so we can write as log a raised to m. Suppose if it is 3 into log 2, if there is a number, or else we can say the coefficient of log is 3, so this we can write as what? Log 2 cube. Okay, so this is the first formula which you have to remember. So we can bring this power to the down. Okay, or else this will go up. So this two formula you have to remember. The second formula is what? Log e. Wherever you see log e or 1, wherever you see log e, you will replace the log e by 1, or just you see 1 only 1, so in place of 1 directly you can write as log e, because log e is equals to 1, so 1 can be equal to log e. So in place of 1 we can write as log e. So remember, somewhere if you are getting the step like this, log e equals to, so log e is what? Actually in logarithm the value of log e is equals to 1. And suppose if you want to replace this 1, this replace, if you want to replace this one, so we can write this one as log e. Okay, so I will explain when you have to do this step. Okay, okay, and log e value is 1, and only if the value of e, the value of e, only the value of e, log e and e is different. Okay, so value of log e is 1, and only the value of e is equals to 2.718 approx. The value of e is 2.718. The value of e, only the value of e is what? 2.7. To 2.7, can I say 2.7 is what? It is greater than 0. 2.718 is what? Greater than 0. Yes or no? Because 2 is what? It is greater than 0. So of course 2.718 will be what? Greater than 0. So here the value of e is what? 2.718, approx 2.718. So here clearly we can see that if somewhere if you are getting e, only e, so that e you have to replace by this value 2.718, and 2.718 clearly we can see that it is greater than 0. If it is greater than 0, and we all know that when it is greater than 0, what exactly we have to write for this types of sum to determine whether it is maximum or minimum, so that we will see afterwards. Okay, just remember this basic things about the logarithm. The first formula, log a raised to m, we can write as m into log a. Here we took some example. Okay, m into log a we can write as log a raised to m. The value of log a is 1, or else in place of 1, wherever you will see in this sum, while solving the sum, wherever you come across 1, you can replace that 1 by log e. And the value of e, only e is what? 2.718. and 2.718, clearly we can see that it is greater than 0. Okay, so now we'll move on to the next. Can I say this formula look like this, m into log a? So we'll consider this as m. So minus 2 into log e, we'll consider this as m. So using this formula, so can I write this as log e raised to minus 2, yes or no? Using this formula, yes or no? Okay, so now we'll keep this log as it is. Now for this e raised to minus 2, I will apply this formula, indices formula, a raised to minus m. So a raised to minus m we can write as a raised to m. So further this e raised to minus 2 we can write as 1 upon e square. Understood? Once again I will explain. Minus 2 into log e will apply the logarithm formula. So we can write this as log e raised to minus 2 will go to the power. We'll keep this log as it is. Now e raised to minus 2 will apply a raised to m, a raised to minus m formula, indices formula. So this can be written as 1 upon e square. Yes or no? Understood? In the same way, if suppose here it is minus log e, so here nothing is there. So coefficient of log, can I say it is 1? So in the next step, if we apply the same formula, m into log a, so this minus 1 will go to the power. Okay, we'll keep this log as it is. Now we'll apply a raised to minus m formula, so this we can write as 1 upon e. So you have to remember this two things. Whenever it is minus log e, so this can be written as log e raised to minus 1. So here nothing is there, so we can write as 1. So log this e raised to minus m we can write as 1 upon e. Suppose if it is minus 2 into log e, so this we can write as log e raised to minus 2. So we'll keep this log as it is, and e raised to minus 2 we can write as 1 upon e square. So these are the basic things which you have to remember before dealing with this sum based on the logarithm. If you don't know the basic concept about the logarithm, so it will be difficult for us to solve the sum based on log. I hope you all understood the basic things about the logarithm. And the last one, that is derivative. Of course here we know that whenever we have to find the maximum and minimum, there we have to find the first derivative and the second derivative. So and derivative of log x will be what? 1 by x. So this log x derivative, I hope you all might be knowing. So derivative of log x is what? 1 by x. So let's begin with the step now. So here we have f of x. So after that we have to find the first derivative. I hope you all understood all this concept. Watch this video at least 2-3 times. Okay, so then only you will come to know exact meaning of this concept. Okay, what exactly I did, okay, for these steps. Okay, just go through this video 2-3 times. Okay, so without knowing these basic things, it will be difficult for us to solve this sum. So that's why I had explained this basic things, and this all things actually it was there in the derivative part, and even it was there in the 11th standard also. Okay, so now as per the rule, we know that step number one is what? F of x you will have, then you have to find the f dash x. As in the f dash x, clearly we can see that how many terms are there? There are two terms. And what is the connection? That is multiplication. When it is multiplication, we know that we have to apply u into v rule. And what is u into v? U into derivative of v plus v into derivative of u. I hope you all might be knowing this formula. Okay, as we cannot derivate this part individually, x and log x, as clearly we can see that the relation between these two is what? Multiplication. If it is multiplication, we have to apply this rule. So let's begin. So x into derivative of log x will be what? 1 by x. Log x will keep as it is, and derivative of x is what? 1. So here x will get cancelled, so we left with 1 plus log x into 1 is what? log x. So here we got the first derivative answer. Now after that we have to find the second derivative test. So one derivative is what, a 0, and derivative of log x we all know that it is 1 by x. So therefore f dash double dash x is equals to 1 by x. So here we got the second derivative answer also. Yes or no? So in this sum also you have to apply the same procedure. Okay, step number 1, step number 2, 3 and 4. Just the change is what, the change is the question. The question is what, x into log x, that is a change. And the function, the presentation part, the procedure to solve the sum, it will be same, the technique will be same for each and every types of the sum. Whenever you have to determine whether the function is maxima or minima, see to it that you have to follow this same step. As this question was little different from the previous two questions, so that's why I'd explain some basic things about the logarithm first, and then we started with the presentation part. Okay, so now again the same step we have to follow. So here we got the f dash x and f double dash x. So after that, what is the next step? Okay, so now the next is what, we'll put first derivative equal to 0. So what is the first derivative answer? That is 1 plus log x equals to 0. So we'll keep this log x as it is, and we'll shift this 1 to right hand side, so that will be minus 1. Okay, so now as we have to find, as we know that when you put f dash x equals to 0, so there you will get the value of x. So in simple language, here we have to find the value of x, not the value of log. So here we have to remove this log. Okay, so to remove this log, so there are some points which you have to remember here. So you can both this side make the both the side log. So there is one property, if left hand side is log x equals to log a, okay, so this can be written as x equals to a. If left hand side and right hand side contain both log, okay, so this log will get cancelled. Okay, not cancel like exactly, when you take anti-log on both the side, so this log will get cancelled and you will left with what, x equals to a. Just remember like this, whenever you have log something equals to log something, log will get cancelled and you will left with that x equals to a. Or else by using this formula also, log b to the base a equals to x, you can find your answer of x. So here in base nothing is there, so we can take the base as e. Yes or no? Common base as e. So using this formula also you can find your answer, but I will suggest to apply this first step. Okay, so as we know that, as just now only I had explained, whenever you come across 1 1 1, so can I write this 1 as log e? Yes or no? So when you will write 1 as log e, whenever you see log in the left hand side, whenever you see log in the left hand side, and here you have just 1, so you can write this 1 as log e. Okay, after this, as per this rule, we must require log something equals to log something, and see to it that the coefficient of log this part, it should be same, it should be 1. So here it is 1, here it is minus 1. So first, here nothing is there, so we'll write 1. So using the formula m into log a equals to log a raised to m, so we'll shift this minus 1 to the power. Yes or no? Okay, so remember this step, whenever you have left hand side log and here right hand side 1 is there, so with this 1 we can write as log e, and further this minus 1 we can shift this minus 1 to the power by using this formula. Okay, so here clearly we can see that here we are getting what, log something equals to log something. So we can apply this formula. So x equals to what, e raised to minus 1. So therefore x equals to e raised to minus 1, using a raised to m minus a raised to minus m formula. Okay, a raised to minus m we can write as 1 upon a raised to m. So e raised to minus 1 we can write as 1 upon e. So here we got the value of e. So once again I will explain this step. Okay, so here 1 plus log x, it was equals to 0. So we'll shift this plus 1 to the right hand side. So as I told, whenever you see 1, you can replace the 1 by log e. When you have to replace this 1 by log e whenever you see log in the left hand side. See to that. Okay, okay, focus on my words, what I'm saying. You will replace this 1 by log e when you see log in the left hand side. So further, this minus log e, here nothing is there, so we can write as 1. So this we can write as log e raised to minus 1 using the formula m into log a, that is log a raised to m. Yes or no? This all things I had explained just now only. Okay, after this, using the formula log something equals to log something, so taking anti-log on both the side, you will come to the conclusion that x is equals to a. So the same thing here will apply. So here you will get x equals to e raised to minus 1. So x equals to e raised to minus 1 we can write as 1 upon e. Okay, so here we got the answer of x, that is x equals to 1 minus 1. So in the step number 2, as I told, whenever you are getting two answers, so one value will turns to maxima and second value will turns to minima, or vice versa. Whenever you are getting only one value of x, so see to it that either it will be maxima or it will be minima. So here we got only one value of x, so common sense, either the value of at x equals to 1 upon e, it will be maxima or it will be minima. So now we'll check. At x equals to 1 by e, the function is what? It is maxima or minima. So now for, we'll write here for x equals to 1 upon e, to check whether it is maxima or minima. So we know that from the first derivative you will get the value of x, and the value of x you will substitute in second derivative, so where you will come to know the function is maxima or minima. An exact value will get from f of x. Okay, so we got the value of x. Now we'll check whether the function is maxima or minima. So what is f double dash x? So here f double dash x is what? 1 upon x. So now we'll replace this x by 1 by e. We'll replace this x by 1 by e. So this e will go up, so this will be what? E upon 1. So e upon 1 is what? E. So here we got the answer of second derivative, and we know that e is what? The value of e in the logarithm is what? Approximately it is 2.71. Yes or no? 2.7. So 2 point means what? It is greater than 0. So here if I replace this e by 2.718, so of course this 2.718, clearly we can see that it is greater than 0. If it is greater than 0, so if the value of second derivative after putting the value of x, if it is greater than 0, so function is what? Minimum. Okay, so just now only I had explained the value of log e is 1, and only e, the value of e, approx value of e is what? 2.718. So if we replace this e by 2.718, so clearly we can see that 2.718 is greater than 0, positive value na, because 0 will come here and 2 will lies here. Yes or no? So it is 2 is what? Greater than 0. So therefore, of course, at 1 upon e, when you substitute the value in the second derivative test, here we are getting what? Greater than 0. If it is greater than 0, so here we can write what? The function. Okay, that means that is f of x is minimum at x equals to 1 by e. Now we have to guess the exact minimum value. To guess the exact minimum value, so we all know that where we have to substitute the value, we have to substitute the value in f of x. So what was the f of x? So f of x, it was x into log x, x into log x. Okay, so at x equals to 1 by e, yes or no? So x is what, 1 by e into log, will replace this x by 1 by e, yes or no? So 1 by e will keep as it is, and log, can I write this 1 upon e, as here nothing is there, so e raised to 1. So 1 upon e raised to 1 we can write as e raised to minus 1, as this all things I had explained here. If e raised to minus 1 we can write as 1 upon e, so 1 upon e we can write as e raised to minus 1. Understood and out till here? Okay, so now after that 1 upon e, can I write this minus e, log e raised to minus e, using this formula log a raised to m, that is m into log a, will bring this minus 1 down using this formula, yes or no? Log a raised to m equal to m into log a, yes or no? Okay, so in the next step, 1 upon e into minus 1 into, we know that value of log is what, 1, yes or no? So further the final answer will be what, 1 into minus 1 into 1, you will get minus 1 upon e. So this is the final answer of minimum value at x equals to 1 upon e. So once again I will explain this step. To get the minimum value, so you will replace the value of x. To get the minimum value, you will substitute the value of x in f of x. So f of x, it was x into log x, so we'll replace the value of x by 1 by e. So clearly we can see that here I had replaced the value of x by 1 by e, 1 by e. Okay, so this 1 by e we can write as e raised to minus 1. Just now only I had explained this part. And log e raised to minus 1 we can write as minus 1 into log e, using this formula, logarithm formula. And we know that log is what, 1. So 1 into minus 1 into 1 we can write as minus 1 upon e. So this is the final answer. So I hope you all understood this sum also, and the same sum it is there in the exercise number 4.3, question number 1. That's the second sum, and this sum it is very important sum as board point of view. I know the sum is little different from the previous two sum. The previous two sum was algebraical, and this sum it was the combination of algebraical and logarithm. So before dealing with this sum, see to that you must know the basic knowledge about the logarithm. So first see all this basic concept and then solve the sum. I hope you all understood all the sums of your exercise number 4.3. As now we done with the question number 1 of exercise number 4.3, and in the exercise number 4.3 there are 4 questions. So your question number 1 is what, to determine the maximum and minimum value of the following function. So now we are done with the question number 1, and the next lecture we'll see the question number 2, 3 and 4. So in the next lecture we'll finish this exercise. So I hope you all understood all this sum. Okay, so for this sum just watch the video 2-3 times, that's it, and all the things it will be in your mind. Okay, and this sum actually it is not that much difficult also, it was very easy sum. And just remember one thing, whenever you are getting only one value of x, see to it that either it will be maximum or it will be minimum. So that's the end of the lecture. In the next lecture we're gonna do the remaining sums of this exercise. So till then, goodbye, see you in next lecture.